All right, so we know parallel lines. This should not be news. Parallel lines are two lines that would continue on forever in both directions and never cross. So these are parallel lines.
Like a number line?
Sure. It goes on forever. These two lines will never cross. If one of them is even a little bit tilted, at some point, they will cross. They have to both be perfectly straight with the same distance apart all the way across. Bless you. Bless you again. Now, this new word, this word, sounds weird. It's new. A transversal is pretty simple. I'm going to use a note card as a straight edge. So if I have two parallel lines, like a railroad track, that's going on forever, and then I were to put a road across the railroad track, that road that crossed the tracks is called a transversal. So the transversal is that. It is a line that cuts across a pair of parallel lines. A line that crosses parallel lines. Crosses, I ran out of room, parallel lines. A line that crosses parallel lines. So a transversal is not scary. That's all that means. If you ever have two parallel lines and something goes across it, that's a transversal. So think like roads and railroad tracks. All right. Now, when we talk about this situation, there are some rules that when you think about it, probably just kind of make sense. One rule is that in between the lines is called the interior. So this space is called the interior. It's inside the lines. Interior. Take these off. I'm jingling too much. So if in between the lines is interior, outside the lines would be exterior. See, it all just makes sense. So interior, we'll go me and my color palette. So then out here, this is exterior, and this is exterior. So you have inside, outside, interior, exterior. Now if we review our angle relationships we've already learned, if I'm just looking at this relationship, these two lines that go across like that are called what? These two angles. What relationship do they have? There's two choices. Are they complementary? These two? No. Are they supplementary? Yes, because they add up to a 180 and they're adjacent because they're side by side. So we know that these two angles have to add up to 180 degrees. What about across from each other? What do we call those? Vertical, there it is. So, and we know that vertical angles have what makes them special? What do we know about those vertical angles? Yeah, they're the same and they're on the opposite sides. So, if I take that idea that vertical angles are equal, I'm about to kind of apply that to some other things. I know that these two add up to 180. These two have to add up to 180. And these two have to add up to 180 and 180. Okay, each pair makes up a straight line, so 180. Now, parallel line, special, because if you took this and you like did a snapshot and you copied it and you pasted it right there, it's identical. So this set of angles is identical to this set of angles. Doesn't change. So this one is identical to that one. This one is identical to that one. Same spot, same place. If you took a screenshot and you went and then you pasted it right there, that's the same. That's called corresponding angles. Those are corresponding. Correspond. Thank you. I might have to zoom out. Corresponding angles. It's like a copy paste. So if you copy this and pasted it there, same, corresponding. So this angle corresponds to this one corresponds to that one. To help me talk to you about the angles, we're going to name them. Basic something. I'm going to go make this one a 1, a 2, a 3, a 4, and then 5, 6, 1, 2, 3, 4, 5, 6. Got to keep the pattern. 7, 8. Just so I can get my fat fingers out of the way. So angle 1 and angle 5 are corresponding angles because you copy it and paste it. Angle 3 and angle 7 are corresponding angles. Copy paste. Yes.
Is this like a dilation?
No. No. I was going to say maybe, but no, I don't think so. If there are relations, I don't know what they are. So some examples of corresponding angles. Angle 1 and angle 5. Angle 4 and angle 8. Let me say angle 2 and angle 6. There's multiple. There's not just like one set. They're the matching ones, 2 and 6. Another fun relationship. Alternate interior angles. So I'm going to write it. Alternate. What does the word alternate mean? Change, switch, change, switch, both, alternate. So when you alternate speaking, like when y'all get in partners and somebody says alternate speaking about blah, 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 you switch back and forth. So alternate interior. Which part is the interior? Inside. Angles. So we're going to switch inside the parallel lines. So if you had to guess, if I said 3, what is 3's alternate interior angle buddy? Alternate. You got to 6. Because you got to alternate to the other side of the line. So like if these were in a group and these are in a group cut by that line, if you go here, then this is alternating on the other side inside the parallel lines. So they're not side by side, so they're not adjacent. And they're opposite sides of the transversal. Opposite side of transversal. That is a mouthful. So an example would be angle 3. I'm going to put 2 swoops through 3 and 2 swoops on 6. Because, fun fact about alternate interior angles, they're equal. Because if you think about it, 3 and 2 are vertical angles, so they're equal, and 6 is just a copy of 2, so 6 is equal to 2. So if 3 and 2 are equal, then 6 and 7 must be equal to 2 and 3. So 3 and 6 are equal. So angle 3 and angle 6. As an example, 4 and 5 are also alternate interior angles. They're just a different pair. All right, other one, alternate, which means to do what? Which? Exterior, which is where? Angles. So we've got alternate exterior angles. Thank you. Oh, why did it zoom in? Don't zoom in. All right. So we've got alternate, which means opposite side. Of the transversal. And on the outsides. So 8's partner would be what? 7's partner would be 2. So if I did 8, I'm going to give 8 3 swoops. 2, 3 swoops on 8. So 1 gets 1, 2, 3 swoops. And again, if if 8 and 5 are vertical and equal, then 4 and 1 are also equal. So 8 is equal to 1. They're also equal. Basically, you have 2 measurements here. You have the big one and the little one. All the little ones are equal. All the big ones are equal. All right, last one. This one's extra fun because it's a little different. Same side. Oh wait, I didn't write an example. 8 and 1. 8 and 1. Last one is same side interior angles. So alternate means opposite sides. So same side means not the opposite side. So obviously same side of transversal. Let me just give you an example. Thank you. So if I'm talking about angle 5, what is its same side interior angle?
4?
Same side, not alternate.
Oh, 3.
3. So you're looking for these two. So 5 and 3 are same side interior angles. Inside parallel lines. Same side transversal. So angle 3 and angle 5 are examples of that. Now, are angle 3 and angle 5 equal to each other?
No.
No. But what do they do that makes them special? Anybody have a guess? What makes? They add up to 180 degrees. These two angles right here will add up to 180 degrees. Because if 5 is equal to 8, then 8 is equal to 4, and we know that 3 and 4 have to add up to 180 degrees. So 5 and 3 add up to 180 degrees.
Can you go over that again?
Okay, yeah, it's confusing. So 5 and 8 are equal because they're vertical. And I know that 4 is just a photocopy of 8. So if I take this and I'm like, oh, okay, well, I take that copy, paste it up here. So 8 and 4 are equal, and these two make a straight line. So they have to add up to 180. Basically, your little measurement and your big measurement add up to 180. And this one's a big one, and the little one add up to 180. It gets easier with practice. Since I don't have measurements on here, it gets kind of confusing because we're just all over the place. All right, that's basically it. I'll help you with some practice problems.